Hello everyone. My name is Cesar. I currently work as a data scientist and a machine learning engineer. In this session, I'm going to talk about how I became a Python first developer after working for many years in the Java ecosystem. I did research over there, and also I did application development, like in real systems. And most of my data analysis I was doing before, it was in R, which is uh, the another programming language that is used for statistic. So my promise is that by the end of this session, you will get an opinionated but genuine, useful blueprint of the frameworks, the tools, and the workflows that can help you to be more productive. And this workflow will give you, it will have a positive impact on your how do you develop faster with the modern Python. So hopefully you will get a clear idea on how to go from ideas to working API quickly after this. So let's dive in. So for context, in mid-July of this year, I wrote a blog post titled "I'm switching to Python and actually liking it." And the idea of the blog post was to share my learnings when working only with Python after transitioning from a data engineering oriented role that I had towards a data scientist role. And this blog post is basically a list of the tools that I use for fast prototyping of applications and ideas, and also the stack that it is needed to ship modern applications faster without compromising software engineering good practices. So, in particular, I was interested in reducing the gap between notebooks and experimentation and deployed the service in production. And to my big surprise, the blog post resonated very well with the practitioners across different languages and backgrounds. It received quite a lot of attention on Hacker News, and it was actually in the top page for a while. So yes, I made it on the top of Hacker News, and many developers commented about it. And well, it actually received 695 comments in total, and this is another proof that the Python ecosystem is quite vibrant. And this is also a proof for me that you really never know what people on the internet are going to find interesting. But one thing that is very interesting for me right now is AI. And after being working in traditional machine learning for a while, I see AI like this new hot thing going on that I really want to learn and try and get hands on with it for real. And guess what is the de facto programming language for AI development these days? Yes, you got it. Is Python. And the thing is that the Python ecosystem is already full of tools for machine learning, MLOps, data visualization, data processing, and so on. So already it is quite complex, and with generative AI, there are many more tools and frameworks that are joining the party. So it is very easy, especially for starters, to get lost in this big ecosystem, and it is also difficult to know like where to start. So uh, that is quite a challenge right now. And for many of us, like the natural place to start is with the Jupyter notebooks because it is very convenient. We have uh, all that we need over there. It's very easy to spin up like a Docker container with Jupyter, and we know the pattern. You get a question to answer or an interesting problem to explore. You collect some data, build a pandas data frame, produce a chart, and you feel happy about it because it is very visual. Uh, but the problem appears when you are asked to productionize the notebook, and the issue is that notebooks are not designed for this. So I think of notebooks as the lab environment and applications as production ready product lines in a factory. So, for example, it has happened and to me before that I was doing a quick notebook just to get some numbers, and then I forgot about it. And 1 or 2 months later, when I was asked about the same numbers, I couldn't find them, and I have to elaborate the notebooks again. So this is a problem. Another well-known issue for of rerunning cells and getting lost because we are always in a hurry, and sometimes we break the orders of execution of these cells. And another issue with notebook is that it is hard to create unit tests for the functions. So uh, it is not possible to build proper application infrastructure with good software engineering practices. But don't get me wrong, notebooks are great for exploration and quick analysis. The problem is that we often treat them as the end of the story. Uh, so our real bottleneck is not like model accuracy or algorithms choice. It is the plumbing that transform analysis into production system. And we sometimes think that okay, with the power of AI, is going to be very easily to transpile from notebooks to production ready code, right? But uh, well, not really. That's We are not there yet. Even assuming that code assistants can write production code directly, I think we still need human developers who understand what is going on, like who people to take ownership of the code and guide the LLMs in the direction that we want. So this is the current situation today. It may change in the future, but today we still need human developers overseeing what's going on. And in this context, the structure is very important on my view. So in my experience, I found that really it's really useful having a monorepo, which is great for code assistants because they have the whole context in a single place. For example, I put the backend, the front end, the documentation, and the infrastructure in one single repository, and this gives a single mental model of the project and also simplifies the dependency management. I also place the notebooks there, so it is easier to productionize that by prompting code assistants and LLMs to automatically convert the notebooks into production code. So here's the typical structure of a project with a front-end and back-end architecture hosted on GitHub. Like this is my way to see this, how to get into this structure. First, I prefer not doing any heavy data processing logic in the front end side in the project UI in this case. So I prefer to separate the front end logic from the back end, and you can use any framework you like for the front end. You can use React, Streamlit, Gradio, whatever. So one way to achieve this is by making HTTP call requests to the project the API, and this is the part that contains the Python code that runs the backend services. I use FastAPI for that, and the key inside here is to keep the browser application light while delegating the heavy lifting and business logic to the service. So notice that it is a good idea to include not only the source code and the unit tests in the backend side, but also the notebooks, scripts, and other files that are necessary to build the application. And of course, the project API is a self-contained Python project, so it needs proper dependency management with the UV log files, a Docker file for containerization, and a proper README file. And in this example, the CI/CD pipeline is handled by GitHub Actions. So we are gonna need this workflows folder as well. And I also let some configurations on project-specific settings for Visual Studio Code, which is my favorite code editor at the moment. And I mean, Visual Studio Code is just super popular. and I like to have these same settings over there. So every time I open the project, I get the same code highlighted and the same plugins and everything, and also for the other developers. And of course, it's important to not to forget the other files that are commonly placed at the root of the GitHub project, like the git ignore or may file of for automating tasks like building, testing, and deploying, and Docker Compose configuration if you want to run the backend and frontend at the same time. And so, yeah, there you got it. This same repository handles data analysis, API implementation, documentation, infrastructure definition, and everything lives together, which reduce context switching and cognitive overhead, not only for the human but also for the LLM. So now I will go through my current Python toolbox, which I share in the blog post, and now uh, I'm going to revisit here. So starting with UV, which is by far my favorite Python package manager and build tool. It is basically all I need to get a deterministic build environment to install and manage dependencies. There are three commands that you need to know. The first one is a UV init to initialize the project. It creates a virtual environment, and the pyproject.toml file. You can see an example of the file on the right side of the slide. And this tom file is the most important file because it contains metadata and the list of dependencies required to build and run the project. So the u another command is this uv add, which is used to add dependencies to the project. And the third command that is important is the uv sync, which sets up the whole project based on existing config files. So in general, UV is great for reproducibility, and the best thing is that it is super fast. So actually, I have done some benchmarks myself, and I found that UV is 8 times faster than the pip when installed UV the lab, and 4 times faster than pip when installed dependencies from the same requirements .txt file that we all know. So, well, and coupled with the UV is ruff, which is actually an ensemble of Python formatters. And ruff is a linter and code formatter, so it helps to keep your code base clean and maintainable. So you can configure with the tom file within the tom file, and there are basic commands like you can run ruff check for linting and ruff format for formatting, and ruff has the advantage of being super fast as well. So it is uh, way better than the other competitors when it comes to formatting the code. Highly recommended. So a popular library that I use is pydantic, which is a great library for data validation and setting management. So you can manage all kinds of configuration settings with it, such as API keys, database connection details, or model parameters as well. And here is a small code example on how to use the pydantic settings class. As you can see, you can automatically load settings from environment files. You can also validate their types and make them easily accessible in your code. And so once you run this code over here, as example, pydantic will automatically load the values of API key and DBUR that you have over there. And these values will be accessible and validated according to the types defined in the settings model object. I also want to mention data classes, which is not a library, but it's a modern Python feature that provides a way to define classes that are primarily used to store data. So here you can see a simple example. You just need to import data classes from data class, and you are ready to use the annotation and get access to special methods like init or EQ, which will be generated via metaprogramming for you under the hood. So I highly recommend you to use data classes as well. So now let's see some other version controls tools that are quite modern beyond Git that we all know. First, I really love GitHub Actions. I think everyone should use them or an alternative if you are in GitLab. And this is a simple code example that compiles and tests the backend of a project. And you can note that this workflow uses Docker to run the tests in an isolated environment. So you can also know that you can run the continuous integration across different operating systems. You can choose from macOS or Windows or whatever. And so I recommend using it for both API and UI pipelines. And I also recommend using pre-commit hooks to run checks and format code before committing. Here is an example of a configuration file that I use. It helps ensuring that the code is always in a good state and follows the project's coding standards. Like for example, I use it to run ruff pre-commit and git leaks, which are two tools before committing my code. So every time I commit this command will run and the code base uh, will be clean all the time. So it's like a guardrail. And yeah, when it comes to infrastructure management, of course, there is Docker. But apart from that, I also like to use make, which this is the GNU command, which is a powerful tool that can help you automate almost anything in your development workflow. I know these two examples that I put over here are very simple, but it will give you an idea, and you can imagine how easily you can add more complex tasks as needed. I prefer using make to create simple shortcuts for common development commands, like instead of remembering and typing out long CLI incantations to run the tests or build the Docker images or start services. I define these tasks in a make file, and then I use to run the commands like make tests or make infrastructure up to spin up all the Docker containers, and voila, it really it works. It's amazing that you can use only these commands to get the whole infrastructure up and deployment. So make is really awesome. It works in all the Linux environments. So yeah, I want to say that transitioning fully to Python has been a very exciting journey for me, especially because I have realized how fast it is to go from an idea to a production-ready solution in Python. So it is really great. It's a growing ecosystem, of course, and with AI these days, Python is getting more and more traction. But it is very important to uh, stay conscious about the importance of having good software engineering practice, no matter what, because you can think that okay, by coding with the LLMs will solve all the problem, but that is unfortunately not the case. You still have to know this well-known good software engineering practices, and you need to know the tools, know how they can be integrated to put safeguards into your code base. And from my side, I really recommend you to start having a template that you can reuse in this way. So you should uh, start committing to a project. You start small. These LLMs are very good for greenfield projects, but when you try to scale, then is where the problems start, according to my experience. And you should always try to measure speed, because sometimes I use LLMs a lot and I relied on them too much, and then I have to go back into the code base and fix small things, and I generate so much code. It's very hard to maintain. And so it's very good to have a template of a project and all the tools for the LLMs to reason about that. And this is the end of my presentation. I hope you like it. You got an idea of the toolings that will make you more productive as a Python developer, and to work with AI together and great and make great projects. So I am ready to take your questions. If you have, please drop it in the chat. And thank you. So yes, I have one question, 8 minutes or so. So first question is, I will read it. It says, for some of us that do not come from a traditional software engineering background, but are dealing with core data science work, this all sounds a bit exotic. Can you recommend a resource of or course to help out? This is a very good question. For me, I have a background in academia when I was doing research, and there I know that from the data scientist point of view, you work with training machine learning models, understanding the data, but it is very important to think that today, if you are not, that is not enough. So today, if you are not able to productionize the output or your analysis, then you are like halfway. So you need, as a professional, you need to be able to put your stuff in production. And for that, you need to follow good software engineering practices. So my recommendation is to uh, start small. So you start with one project, and then you start learning about software engineering good practices, right? So, and then you put the good practices in top of your toy project, and then you start learning about all these tools. So you can start with my blog post, for example. I give you like a blueprint of all the tools that are really necessary, and then you can expand from there. And need to be careful not uh, to be in the temptation of trying to learn many tools at the same time as well. So it's good to have to go like step by step, and to say like, okay, now I'm going to learn Git for real, and then you learn Git. Now look, Git needs a Git ignore file. Okay, this is one file. Oh, now, but I now want to uh, containerize my application, and then you learn the basics of Docker. But I need multiple Docker instances to at the same time, and then you learn about Docker Compose, or a little bit about Kubernetes. And this way you need to scale up like step by step, and learning about this slowly, because that is the only way that you will be actually more productive, being able to maintain real software engineering code bases, real project code bases. This is very important. I have taught this with many other colleagues, that uh, the ability to productionize our code bases from the data scientist perspective is getting very, very valuable. And this is why we have all these roles today, like AI engineering roles, machine learning engineers, which are people who can put these models in production. And in order to be stay at the head of the market, then you if you get these capabilities, right? So next question: do you have an opinion on Marino vs Jupyter? No, I don't know. I haven't tried. So I will check it out after. And you see, this is the way you learn about new tools as well, right? So going to meetups, talking with people who are ahead of the market, you learn about a new tool, then you go explore it, try to put it into your one of your pet projects, and that way you learn about the tool. So another question I'm reading here. It says, or a comment says, great question. The data scientist role is evolving and differently in various settings. How much we enter the software development arena is an interesting area to navigate. Yes, definitely. Like that is the way to go. You need to be end to end to be able to put solutions in production. And now with LLMs is super fast to do it, and anyone can do it. So I think that the more multidisciplinary skill you get, then the better for your career as professional in the field as a data scientist. So another question, it says the overwhelm of attempting to learn all the tools in parallel is very real. Yes, exactly. So it's going tool by tool, one by one at a time, and that is the way to go. There is always this temptation of being on top of the latest shiny thing, and that is why like companies that are more cautious about it. Like they wait a little bit for the market until adopting new tools. So it's good to do that as well. So if you get like something in version 0.x, then you need to wait for version 1 at least to be stable in order to adopt it. Another question, how can a QA engineer be involved in this process? By checking mostly the consistency of the outputs. Okay, this is a question about QA. Uh, Quite interesting. There are many different testing frameworks that you can use. And in Python, you can use PyTest and starting from there. I think this is I'm reaching the end of this session. Yes, another question. I still have 2 minutes. Great. So it says there is still too much work stuck in the notebooks. We all need to put more effort into this. Yes, definitely. As I say, you have always this path of going to the notebook, but the more ready you are to get in production, the the more your capabilities to productionize the things, then the better. So yeah, I think this is the end of my session. My time is up. So thank you very much again for joining, and hopefully see you next year in another PyData Global. Thank you very much. Bye.